Hi everyone, today we will solve this problem's three sums. Given an integer array, nums, return all the triplet num_i, num_j, and num_k. So thus I is not equal to j, I is not equal to k, and j is not equal to k. And num_i plus num_j plus num_k is equal to 0. Notice that the solution set must not contain duplicate triplet. This is kind of easier to understand, but we will also go through the example to see it. So in the example 1 in here, we have num arrays is this part, and then we need to output the combinations of three numbers that's equal to 0. So we have -1, and 2 here is equal to 0, and -1, 0, and 1 here, the sum is also 0. So we return this 2. As we understand the problem, we can ask the interviewer some question like whether all of this is in orders already, or we need to sort it somehow. As we see in this example 1 in here, it is not in orders. Whether nums array in here is empty or not. Can it be empty? So we can see this num length of it is larger or equal to 3. So let's have at least 3 numbers inside the num array. So we don't have to worry about num is not empty. Num is empty. If there's num in here, it's not have any possible, so we just return empty. So I think we understand these problems. Next we will move on to the planning and matching step. So in here we have example 1. We can have the brute force solutions is having 3 for loop, and then each for loops is covered getting at one number, and then add all of the numbers to see if it's equal to 0. So that is the brute force solutions, and that brute force solution will be have the time complexities is over n cubed. So it will take a long time to do that, and so we need to optimize the time complexities. So in order to do that, we will do one technique in the two sums problems. I also have the two sum problems, so if you want to know more about that, please check it out. So in here, if we want to do the two sum and create the optimal solutions, we will have to sort this array. So once we sort this array, it will look like something like this. -1, and then 0, and then 1, and then 2, right? Once we sort it, we will have 3 pointers. So one pointer is pointer here, it may be current, and then we will have like this pointer is left, and then this pointer is right. In the two sum methods, we just have the 2 pointers is the left and right, but in this case, we will need 3 pointers to bring down the time complexity of it. When we have 3 pointers like this, we know that we can add up each number in the pointers. So in here, we can have the sum. This would be equal to the current pointers, part of the left pointers, and part of the right pointers. So with this one, we know that it will be -4 plus -1, and then +2. So this sum will be equal to -3, and it's still smaller than 0. So we know that we need something higher, and this array is sorted already. So we know that we should move the left pointer to the right. So we will move the left pointer here, it will point to left here. So it will keep getting larger in the sum for us. So at this point, we will have like -4. This will be the same. So we know that it's still -3. So we will move the index again. So in here, left pointer is pointing to 0. We will do -4 plus 0 and +2. So in this case, this is -2 and it's still smaller than 0. So we move the left pointer again. When the left pointer is at 1 here, so we calculate it again. 2 here, and it's still -1. It's still smaller than 0. And if we move it to here, so right now it's the left and then the right pointer is part of the same number. So it cannot be the case because we don't want it to duplicate. So in the first iterative there, and then we go through that part, and then we will move the current pointers part to the next one. So the current here should be part to this part, and then the left and then the right will be here. Once we have that, we will do the current we are having is -1 plus the -1 again, and then +2. So at this point, you know that this will be equal to 0. So this part will get added to the array that we want. 2 here. This one will be result array. So when we have 0 in here, we add it to the result array, and then we continue to do that. In this case, a little bit different. We will move both the border. So the left is moved to the right, and then the right is moved to the left here. So right now it's like this, and so we're having the current is -1 plus 0, and then plus 1, And then this one is also 0. So we know that we will need to add it to the array as well. So in here, we will adding another one, -1, 0, and 1. So in this case, we will keep the right and then the left is crossing each other, this part. So right now the right here, and then the left is here. Right cannot be smaller than the left, so we know that this is not the case. So we continue to move the currents by 1. So this part, the current will be here, and then the left here, and then the right here as well. Okay, so we have the current is moved by 1. So at this point, we know that the last current is also -1, and the current number is also -1. So we know we don't want to have the duplicate result in the result array. So at this point, we will skip the -1 here. So we move the currents by 1 here. So the current right now is 0, and then the left pointer, and then the right pointer here. So with that, we have current 0, then 1, and then 2. This part will point 3. So this one is larger than 0. So we move the right pointers. Right now, the right pointer and the left pointer is point to the same number. So we should not have that. So we will end that there. So the current will keep going. But then the left and then the right would be point to the same one. So this one should not be the case. And then we continue like that. Then we will have the current go through on the element in the array. We will get the result array just like what we want. To understand this more, we will do it in the implement step. So in the implementation step, I will do it in Java, but I also have the Python solutions in the description below, so please check it out if you're familiar with that more. So in here, we have 3 sums method. Firstly, we will having a list, because we will return a list of integer in here, so we will create it in outside. So we can do results here. In here, we will initialize to be a new array list here. Okay. So once we have that, we know that for 2 pointer methods, we will need to sort the nums array here. So firstly, we will sort it, .sort nums here. Okay. So when we have this one, we will do a for loop to loop through each element inside the nums array here. So if I equals 0, I smaller than nums.length here. Length here. Okay. We will need to go through each element inside nums array. We do I++ next. Okay, so in here, we will do if statements. So once we have nums arrays at I in here is larger than 0, then we know that it cannot be the case, right? Because if it's larger than 0, then the remainder values cannot sum to 0. If it's larger than 0, we just break right away. So we will have the if statement if I is equal to 0 or nums at I -1 here and not equal to nums at I. This one is capitalized. This one is to make sure that the current value we have is not the same as before. If it's the same as before, then we just skip it. And if this is not equal, then we will calling the toSum method. So we have in here, we will have the toSum method here. And I will pass in the nums here and then the index of it. The start index to make sure we go through everything. So in here, we will do another function, toSum here. Us will not return anything. So toSum. Okay. Let's get in the array integer nums into index here. So firstly, we know that we will do 2 pointers. The first lower pointers will be right after the indexes we have. The height pointers will point to the last element of the nums array. So we have here's low pointers will point to the index right after it. So index +1, and then the height. And then the height will be nums array length -1 here. It's the last index. And we will do a while loop if the low index is higher than, well, not higher than the high index. So when we have the while loop here, we will calculate the sum of 3 numbers. So the sum of the indexes we are setting, and then the number as a low index, and then the number as a of high index here. So in here, we will doing comparisons if the sum is equal to 0. In here, we know that we will need to add it to the result here. We will do result.add here. And then in here, we will adding the list of integers. So we can do array.addList. This one is converting the arrays into an array list. So in here we will pass in index here, and then nums of lower, and then passing the nums of high index. Okay, so once we add it in, we will need to move the lower pointers and move the higher pointer as well. So lower pointers will move by 1, higher pointer will move down by 1. And when we move like this, we will need to make sure the low pointers we are setting in here is not the same with the next pointers. So we will have to do the while loop here. These conditions will need to make sure everything working. So the num pointer of the low pointers we currently have should not equal to the nums of the low pointers that we previous in. So with this, if this is the case, then we will move the pointer again because we don't want to have repeated answer. And then else if here, if the sum is larger than 0, then we know that we need to move the high pointers to make the sums smaller. So the height will be minus minus in here. So next, we just need to do another else conditions. So if sum is smaller than 0, then we know that we will need to move the lower pointers to make the sum higher than 0. So once we have this, we know that's cover all those conditions. So after the for loop in here, we just need to return our results here. So to make sure everything's working, we will go through the examples to make sure everything is tested out. And because in there's interviews settings, you don't have the IDE like this, so you should do it by hand. So we have the number array like this, and we will having a result. So the results arrays will having the empty at first, and then we will sort it the nums here. So this num will be equal to -4, and then -1, and then -1 again. 0, 1, and 2. When we sorted an array in here, we do a for loop. So we start at I at 0. So we start with this number. And this is not larger than 0, so we not break it. So it's come to this part. And I at 0, so it's come to this two-sum method. So this two-sum methods will have the lower is at 1, because 0 plus 1 is 1. The higher bit will be 5. And then we will calculate the sum of it. The first index is -4 plus -1 and then plus 2. This one is not equal to 0, so we will and the sum in here. The sum in here would be -3, right? So -3 is smaller than 0, so we will increase the low pointers. So the low pointer in here is not 1 anymore, but it's 2. So we calculate the sum again. We are having -4 plus -1 again, and then plus 2. This one is still have the sum is -3. So next we move the lower pointers by 1. So in this case we are having -4, 0, and then 2. So the sum of it would be -2. It's still smaller than 0, so we increase the lower more. So lower is at 4 here. So we currently have -4, 1, and then 2. This is -1. And sum in here is still smaller than 0, so we increase the lows again. This is come to 5, and we know that low should be smaller than height, so this part is not getting any solution in here. So next we'll move the I pointers. It will come back here, so it will move the I pointer by 1. So it's by 1 in here. So this is 1, and it will come to this part. So continue with the two sum here. The low pointers will point to 2. The high is still 5. Sum is -1 plus -1 here, and then 2. This one is actually sum is at 0. So we come to this part. It will add an array into here. So we have -1, and 2. 2 here. Okay. And then it will increase the lowers and then decrease the higher. So low would be 3, high should be 4. We come to this while loop to make sure next lower is not equal to the previous one. So we have lower at 3, so we're having -1 here. It's not equal to each other, so we know that it still need to increase the lower here. Next, we will continue to calculate the sum. So we're having -1, 0, and then 1. This is actually equal to 0, so we continue adding it. So -1, 0, and then 1. After that, it will increase the low and the high again. So this part it will coarse. So we know that the height and the low in here is not satisfied with these conditions. So we will end that there. And we will increase this one to 2. And I think we keep continue like that. And then we will get the solution with the result like this. So I think there's a problem in here. It is not or, it should be n. Because we want to make sure that the low is smaller than the high first. In order to do that, to compare this lower. So it should be n in here. So next we will go on to check for all the test case here. So we know that everything is working. So in here we will have time complexities is of n squared. of n squared here. Since firstly we will need to do a for loop to go to n number in here, and then in the two sum in here it will have to go to n as well, so it will be of n squared. And the space complexity of this one it will be of log n, since we're having the array of source here, and this array of source will taking log n space complexities, so it will be log n there. Want to submit this one to make sure everything is working. So we have successful result in here, and this solution is faster than 93% of all Java Online submission for these problems. So if you have any questions, please let me know in the comment below. Also, let me know if you have any problems that you want me to do. And please like and subscribe to my channels and check out other videos as well. Thank you.